Hello YouTube, welcome to my channel. In today's video we are going to look at circuit element, but before we start, don't forget to give me a thumb up if you like the video, and don't forget to subscribe so that way you won't miss out any of our videos. So let's get started. Do you know that every electronic device is made up of tiny little building blocks which we refer to as circuit elements? These elements come in the form of the resistor, the battery, transistors, and all the rest of them. And they are put together in order to enhance the proper functionality of electronic device. Furthermore, they are classified into active elements and passive elements. The active elements are those that provide power for the circuit. Example includes the generator, the battery, the op amp, etc. The passive elements, on the other hand, takes power from the circuit, and these include the capacitor, the resistor, the inductor, and all the rest of them. So in this video, we are going to focus more on the active elements. So let's proceed. The active element, as discussed earlier, provides power for the circuit, and they are classified into two. We have the independent and the dependent. So the independent stands alone to provide its power, whereas the dependent depends on other elements for their power to be controlled. They uses this symbol to represent the voltage source and this symbol to represent the current source. Okay, here is a practical demonstration of the independent power supply. So what we have here is a 9-volt independent voltage source. It is independent because it depends on no current, because there's no current or voltage that will tell it what to do and when to do what it does. So if I lock down this, if I close the switch, it provides the power for the circuit. So I don't need to connect it to any other external current or voltage source for it to do its work. So that is why we call it an independent power supply or voltage source. The same thing goes to the current source. Here is a practical demonstration of an independent current source. So this current source doesn't depend on both the voltage or any other external current for it to do its work. So once I close down the switch, the 30 milliamp current source provides current for the LED to glow light, and that's how independent supplies work. For the dependent power supply, this symbol is used to denote the voltage source, and that symbol is used to denote the current source. Due to their dependency, they can either be controlled by the voltage or the current from the independent source. Because of that, they are classified into four, which are the voltage controlled voltage source, the current controlled voltage source, the voltage controlled current source, and the current controlled current source. This classification is based on the ability to respond to certain adjustments by the external voltage or external current. Okay, here is a practical demonstration of a dependent voltage source. And this voltage source is 2 volts per volt. It depends on other voltage source for it to work. So if I close the switch, nothing is going to happen because it doesn't act alone. It acts with the influence of another voltage supply for it to work. So this dependent source is actually a voltage controlled voltage supply, because we can see the the terminal here, positive and negative, is showing the external voltage supply, how where it's going to be connected to. And here I have 2 volts per volt, meaning per in each of the voltage of the external supply, this particular dependent voltage is going to be 2 volt ahead of it. So if I have 1 volt from the external supply, it is going to be 2 volts here. If I have 2 volt there, it's going to be 4 volts here. So if I have 10 volt there, it's going to be 20 volts here. So that is it, 2 volts per volt. That is the gain of this dependent source. So for this dependent source to actually work, so what I'm going to do is I have to connect a 5 volt independent source to it. So I'm connecting this guy to here, and I will connect this one to this one. And when I do that, I also need to connect this to the ground. So once I establish this ground connection, I can run my circuit. As you can see, it's working perfectly, telling me that this 5 volt supply, remember the gain is 2 volt per volt, meaning that I can easily see that the voltage here is 10 volts. 10 volts, meaning that it has gained 2 times the 5 volt I supply to it. And that's how an independent voltage supply works. So it depends on the voltage outside for it to perform its function. So this particular illustration is for a voltage controlled voltage supply. There is another illustration of a dependent power supply. This is a voltage controlled current supply. This supplies current to the circuit. Now, if I close the circuit, nothing is going to happen because I haven't attached the voltage that will be controlling the current that is supplied to this circuit. So when I connect the same 5 volt supply to it, connect this 5 volts here, connect this to this guy, the voltage, and then connect it to the ground, and then run the circuit, you see that the circuit has glowed because of what? It has supplied 10 milliamp. The gain is 2 milliamp per volt. So if I have 5 volt, it's going to be how many milliamp? It's going to be 2 times 5, and that is 10 milliamps. So that is how a voltage controlled current supply works. Here is another illustration of a dependent power supply. This is a current controlled voltage supply. You remember the first one we discussed was a voltage controlled voltage supply, and then a voltage controlled current supply. This time around, this is now a current controlled voltage supply. The gain is about 2 kilovolts per ampere. So it means in each ampere you have 2,000 volts. So we already have a milliampere. So I have a standard 3 milliamp current supply to it. So when I connect it as usual, connect this to this, connect this to this, and then connect the connect to the ground and run my circuit. I have to close the switch. So I close the switch, as you can see, the current is produced, and this is how a dependent current controlled voltage supply works. And finally, we have the current controlled current supply. So how does this work? It is about 2 amp per amp. So that's the current supply here. So if I connect my usual 3 milliamps to the current, is a current supply to it as usual, and then connect to the ground and close my switch. Okay, it's already closed. So run my circuit. You see that the current is actually glowing. So I can adjust the current from the power supply, and I will be able to have something amazing. Or better say, I adjust the gain from 2 amp per amp to something else. So let's do the adjustment of the gain here. If I adjust the gain, let's say from 2 amp to 3 amp per amp, you see the LED becomes a little bit brighter, and that's how whatever that happens to this current is going to affect this current that is supplied to this guy. So if I change the current supply, let's say from 3 milliamp to 5 milliamp, notice the brightness of the LED unlike before. So this is how this current controlled current supply work. Another interesting concept I want us to discuss about is power polarity. As we know before, we defined power as current times voltage. It is important to note that power is always conserved in a circuit. As a matter of fact, the total power that is lost must be equal to the total power that is gained by the components in a circuit. Now, how do you determine when power is delivered and when power is consumed? Notice the flow movement of current. If current flows from the negative to the positive terminal, power is released and power is delivered by that component. If current flows from the positive to the negative terminal, then you know that power is consumed by that element. And that is very, very important. Now let's try out some few examples to enhance our understanding of what power and its relation is all about. Okay, here is the question. It's the power absorbed or supplied by each component of the circuit below. Now let's take a closer look at this circuit. What do we observe? We can see that we have a 5-volt supply to these elements, which looks like a resistor. And we are asked to find the power P1. We can see another element here, which looks like that of an independent voltage supply. And we are asked to find the power P2. We can see another element here, which looks like a dependent voltage supply. Now, I want you to pause the video and tell me what category of dependent voltage supply is this one element here. Yeah, you got it. It is actually a current controlled voltage supply, because whatever happens to the current is going to affect the voltage. And we are asked to find the 3. The same we have the other element P4. So let's present our information that we are given. Now let's start by finding P1. Now let's trace the origin of this current. What current is this? 9 ampere. What's the origin from this? You can see that the current is actually flowing out from the positive terminal. That is to tell you that it's actually moving in through the negative and it's coming out from positive. So I want you to guess, what power is it? A negative power, because it is flowing out from the positive terminal. So let's figure out what power is. What is power? Power is defined as current times voltage. So when we implement this here, we can see that power 1 is equal to 9 ampere times 5 volt. And when we punch that out, we can see it is minus 45 watts. Power absorbed, power given out by the element. So we've gotten power 1. So let's figure out power 2 from the elements P2. So to find out from these elements, we are going to consider the direction of current. Current is moving in from where? It's moving in from the positive terminal and it's coming out from the negative terminal. So what does that tell you? Power is absorbed. So to figure that out, so what is power? We simply say that power is current times the voltage. So we do that. We have 9 times 2, we have 18 watts. So it's going to be positive because it is absorbed. So we look at power 3. Wow, power 3 is a lot more different here. Now we don't know the voltage that this power 3 it has, but we know the current flowing through it is a 4 ampere. So the voltage is determined by a current I. So to figure out what is I was given to be 5 amp. So when we substitute 5 here into this I will have 0.6 times 5, and that will give me, when you punch that on the calculator, you have 3 volts. Very well. So it means that the whole of this is 3 volts. So when I take these 3 volts and multiply it by the current, I will get a power. So the power there is 3 times 4, and that is 12 watts. So finally we have power 4. So pause the video and try find out the power 4. So P4, to figure that out, let's follow the movement of current. Current is flowing this way. Definitely is going to come down here and it will pass from the positive to the negative. So because it's moving from positive to negative, power is absorbed. So we're going to find the power is going to be 3 volt times current 5. So when we do that, we have 5 times 3, and that is 15 watts. And sure, we have analyzed this circuit and we have found the power absorbed or supplied by each component in this circuit. So let me ask you, which of this power is absorbed and which one is supplied? Obviously, P1 is supplied and this guy is absorbed. The same represent for the rest of them, and that feels good. So that's it for this problem. Let's take up another problem. Now here is a problem. Find the power absorbed by each of the elements in the figure below. So I want you to feel free to pause the video and try out this problem yourself. All right, let's continue. Now notice that this is also an independent power supply, voltage supply. This is also a kind of a resistor or a voltage supply, whichever element is this was still known. So we are asked to find the power of each of these elements. So let's quickly get down to work. So P1, we will say 30 volts. Let's find the current coming out from here. Notice that this current, if we trace the movement, you can see the arrow. Notice that the current actually moved away from the negative terminal to the positive terminal. So it's leaving from the positive terminal. So it means that the power is supplied because current is actually flowing in from the negative to the positive. So power is supplied. So the power that is supplied is 30 times 10, and that is 300 watts. And that is power 1 supplied. So for power 2, feel free to pause the video and tell me what power 2 is. Power 2 is going to be 10 volts multiplied by the current 10 amps is flowing from the positive to the negative. Remember, the first one was flowing from negative to positive. So this one is moving from positive to negative, meaning it is what? Absorbed. So when I push that out, it's going to be 10 times 10, and that is 100 watts. This is negative because it is supplied. This is positive because it is what? Absorbed. So that's for power 2. Power 3. So how do we figure that out? Power 3 has how many volts? 20 volts, and the current is what? 14 ampere. So when we quickly punch that out, you will see that we have 20 volts times 14, and that is 280 watts. And that is it absorbed or supplied? It's also absorbed. So they are absorbed. Now we have power 4, P4. To figure out power 4, let's monitor the movement of current. Notice something. Current is flowing from negative to positive terminal. So did you get that? 4 amperes flowing from negative to positive terminal. So because of that, we say that this power 4 amp is supplied. So we quickly figure that out. We say that this is going to be 4 times 8, and that is 32 watts supplied. Is going to have be at the negative sign. And finally, P5. So what do we have? Notice that this is a dependent current source. So it means that the current depends on some voltage. So we don't know the current. What's the current here? The current here is what we don't know. So to determine the current here, we are going to figure out what is dependent on, because this is a current controlled current source. So to get a power, we already know the 12 volts. So this 12 volts times the current is going to be determined by I. Where is I? Over there. I is 10 amperes. So we multiply 0.4 with I, 10 ampere, and we have 4. So the whole of this is 4 ampere, and that's the current of this particular source. So when we multiply 4 ampere with 12 volts, we get the power. So 4 ampere times 12 volts, so we have 48 watts. Now notice the direction. Current is moving from negative to positive, and that means that the power is what? Power is supplied. So it is going to be negative power. And that's it. Pretty simple. That is how to figure out, solve problems with the knowledge of circuit elements. Alright, that's gonna do for this video. I will see you guys in the next video for an amazing episode on network analysis.